Okay, in this video, we will discuss about very important concept in the linked list. That means reversing of a linked list. In the reversing of a linked list, there are two kind of thing we can do. The first one is the naive approach, and second one is the efficient one. First one is the naive approach. In the naive approach, what we do, we are using a stack and insert the item into the stack and popping out into the one by one. So that is happening. So that after popping out every element, we will get the reverse order. You can see here. Yeah. For here, we can see here. So first the element will be reversed. We are passing the element. We are creating a node here. Then what we do, we are reversing of a list. We are passing the linked list and we're creating a stack. Stack means an array we are creating and we are do the current equal to current dot head until it will be none. We are doing the while loop. Then stack dot append of current dot key. First key inserted and then current equal to current dot is then second key inserted and that can be done in the loop. And once the items are available in the, for example, after this step, okay, after this step, here what we, after this step, like we have a stack, right? Stack, inserting into stack. So that completed. So that means first we inserted 40. Okay. So you already know we need to append the key one by one. Okay. That means 40. First 10, inserted 10, then 20. Okay, because we are creating, once we create this node, it is passing to here, right? This one. So first we are inserting 10, append, okay. 10 we are passing, append, stack dot append, that means 10 inserted, then 20, 30, 40. Then the next loop, what we do, we popping out the thing. Okay. So popping out means picking the one by one data like in the stack. So stack pop, that means we will get last item first. 40, 30, 20, 10. So this is happening, we get. So that is the reason. First we insert the item, all the item appended, then pop. Simple append and pop operation using this reverse of a linked list. And we can do a efficient solution. In the efficient solution, what we do, we are creating, for example, I will tell you, uh, so I will creating a linked list, for example, like um 10, 20, 30, 40. So this is the link, this also link, this also linking, and this will be null. So what we do in the reversing of a list, we are breaking these links, okay? We are breaking these link and reverse this link, like reversing a link like paint. I will reverse this one like this. Already in the reversing of a link, it will be reversing to back. So 10, 20, 30, like this. That means the reversing of a link. So that we need to do in here also. You can see here, first we are creating the nodes here, then run the node like 10, 20, 30, 40. So after this, we reverse the list. We are keeping a current equal to head and previous equal to none. While current not is none, we are looping same as like that. And at the breaking time, we are keeping the item next equal to current dot next. We are keeping it, and current dot next equal to previous, and previous equal to current, and current dot equal to next. So this four condition will be doing here. That means I will tell you the first case means we already know if we need to break this one. For example, 30, 20, we are simply reversing this link. So link like this, right? So first we break this one and opposite do it. Okay. So that is the reason we are next equal to current dot next. We are keeping that one. Then current dot next. Okay. Means current, this is the current element. Then we looping it current dot next equal to previous one. So then only this current next value will be previous. We are holding it, right? Previous. Then this link is we simply changing here. So next equal to we are assigning current dot next. We assign one variable next. We need to keep it. Keeping the next element 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 before breaking, then only we can hold that value breaking before breaking, and current dot next, that means we need to simply link reversal. So this is happening here, link reversal, and previous equal to, then we change it, previous equal to current. Okay, previous we are assigned to the next node, the previous equal to current, and current equal to next. Then this loop will work until current equal to this one. So the time complexity means, you already know, that means we need to take it n times. So the time complexity will be big of n. That means n time need to iterate. And the space complexity, we are not keeping anything here. So the space complexity will be big of 1. There is no item need to do. Okay. The space complexity is big of 1. But in the case of here, you can see here we are using a stack. So here the stack size we need to consider. The time complexity also bigger of n, and space complexity need to consider as the stack. So yeah, this is all about the reverse of a linked list and with the efficient solution and a naive solution. So if you have any doubt, let's comment below. Okay.